Okay, let's get in there. Welcome back to our video assignment. So this is the second one. Today we will be looking at 2-methyl 3-octane. So let's go ahead and jot that down, 2-methyl 3-octane. All right, so first and foremost, let us do the line angle structure for this molecule. So I'm going to start down here. So we have 8 carbon in our carbon chain. So let's do 1, 2, 3, 4, 5, 6, 7, and 8. All right, so we got that down. And then it also says here that we have a methyl group on our second carbon. So let's go ahead and draw our methyl group. And this ends, the suffix is an -ene, so that will specify that we have an alkene, which is 2 carbon bonds. So that is going to be on our third carbon. So 1, 2, 3, and we draw that to the 4th carbon. Okay, so next we're going to take a look at our hydrogenation. Ugh, it's a tough word to say. Hydrogenation, or hydrogenation, whichever. Our hydrogenation reaction, and pretty much that is adding +2 hydrogen. It's pretty simple. So we're just gonna draw our little diagram over again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, plus an H2. And then when we do a hydrogenation reaction, there's always going to be a metal catalyst. Sometimes it can be platinum, palladium, and nickel. But we're just going to make it easy for this case. We're just going to use platinum. So pretty much what we do in a hydrogenation reaction is we're adding 2 hydrogen. And essentially what that will do is it will take away our double bond, and the hydrogens will go in place of that double bond. So what it will look like now is pretty much 1, 2, 3, 4, 5, 6, 7, 8. So before, where we used to have our double carbon bond, we added the 2 hydrogens, so now that just completely gets rid of it. So now what we have, let me see, is a 2, oops, I forgot my dash, 2-methyl octane. So because we got rid of our CC double bond, that changed this back down to an alkane. So that's where I changed the suffix from an octane to an octene to an octane. Okay. So next we are going to be looking at our hydration reaction, and the hydration reaction was a little bit more complicated, to me at least. Hydration. And essentially what that's doing is we're adding water to it, so H2O. That's a little H2O. And let me just get this down. And in this reaction, it uses +2 hydrogen. +2 hydrogen as our catalyst. So it's kind of different from up here. Up here we're adding 2 hydrogen, but here, I mean, we're essentially adding 2 hydrogen, but we're adding a hydrogen and an alcohol group. So this will end in an OL. So we do have to change that. So let's just keep that in mind. Oops, and I forgot my double bond. So pretty much it's kind of the same, but a little bit different. So it's broken, these break up into 2. So these break up into a hydrogen, a plus hydrogen bond, and an OH group, an alcohol group. And pretty much the hydrogen, the example was the rich get richer. So the hydrogen will want to go to whichever end has the most hydrogen, but because they're pretty equal We can just place it anywhere, but I like to start from the left to right. So let's just draw this over again. All right, hydrogen. Okay. So this will get rid of our carbon double bond. And pretty much this little guy will attach himself there. So this guy now has 2 carbon, and then we make another little group up here where our alcohol group will go. So this will now become 2-methyl 3 oops, sorry, I'm so sorry, that was wrong. 2-methyl 4-octanol. And yeah. So let's just make sure the work is correct. So we added hydrogen, so we added our 2 hydrogen, that became this. So this right here is our product for our hydrogenation reaction. And so we added H2O, so the H stuck itself on our 3rd carbon, and our oxygen group stuck itself on our 4th carbon because the rich get richer. And our product for this end is 2-methyl 4-octanol. Let's get that back in there. And yeah, awesome. See you later.